In the next problem, we have the directions to solve the equation and solve for any extraneous roots. And in solving this problem, my first goal is to eliminate the denominators. And to eliminate the denominators, I really have to look at any denominator which can be factored. This denominator can be factored into x minus 2 times x minus 4. And if you notice that the other two denominators, each of them has one of these factors. So what we're saying here is that the least common denominator, least common multiple, will be x minus 2 times x minus 4. And remember the golden rule of algebra: what you do unto one side of the equation, you will do unto the other. So on this side of the equation, I will multiply by x minus 2, x minus 4. And on the right side, I multiply by x minus 2 times x minus 4. In multiplying, don't forget that you have to distribute. And when I distribute this least common multiple times the first fraction, the x minus 2's cancel out, and I end up with x times x minus 4 plus the same least common multiple or least common denominator times the second fraction. The x minus 4 factors cancel out, and you have 3x times x minus 2. On the right side, things are a lot easier because both of these factors will cancel out with both of these factors. So you end up with just the numerator. Okay, I have some simplifying to do. I have the distributive property to use for each of these two. And now I have a quadratic equation. And we know there are many methods for solving the quadratic equation, but the one that we try first is factoring, which means we have to set the one side equal to 0, and I choose to bring these two terms over to the left. We have two x squared terms, which give me 4x squared. Then I have negative 6x and negative 4x, which gives me a negative 10x, and I'll add 2x to that, which gives me a negative 8x. And I have one constant term, the 32. When I bring it to the left, I have a negative 32, and now all of that equals 0. To simplify matters, I notice that each of the three terms has a common factor of 4. So I'm going to divide through by 4. Notice every term got divided by 4. So I simplify the matter by getting negative 2x minus 8 equals 0. Once I get there, it makes my factoring a lot easier. I ask myself, what two numbers multiply to give me a negative 8 but add to give me a negative 2? And that would have to be a negative 4 and a positive 2. Set each factor equal to 0 and solve. So you have x equals 4 for this one and negative 2 for that one. Now you would think you'd be finished. However, it did say to check for any extraneous roots. Extraneous roots occur when you change the form of the actual original problem. We changed this from a rational problem to a quadratic one. And in that process, you can come up with some answers which don't really fit the original problem. So I will take a look at 4 and ask myself, when I put 4 in this equation, will it cause the denominator to go to 0? Well, it definitely does here, and it will here as well. So positive 4 will not be one of my solutions, so I'll cross that off. Now when I check negative 2, when I put negative 2 in the first denominator, it's not a problem. It gives me negative 4. When I put a negative 4 here, it gives me a negative 6. So it doesn't turn the denominators into 0, which would make this whole thing undefined. So in the end, we have one extraneous root, and the final solution would be x equals negative 2.